Okay, today we're going to be talking about radical and exponential functions and how to graph them. And this is lesson 7.7 in your textbook starting on page 269. So what a radical function looks like is just this, function of x where x is underneath a radical sign. An exponential function is where x is in the exponent position. So today we're going to be talking about both of those. So if we look at first the radical function and how to graph them, what I want you to do is to make an XY chart with 5 places in it so that you can pick X values and then figure out what the Y values will be. So in this case, if we pick 0, 1, 2, 3, and 4. So we have our f of x equals the square root of x. If you recall, on Wednesday I told you that you cannot have a negative number, and I've mentioned it before throughout the year, you cannot have a negative number underneath a radical sign right now. So we have to make sure that everything that's underneath the radical sign is greater than or equal to 0. And in this case, it's only x. So we just have to make sure x is greater than or equal to 0. So that's how we can start with 0 and go down with these numbers. We could have also picked, so we could have picked those, 5 numbers if we wanted to look at just the first 5. We can also pick random other numbers like 1, 3, 4, and 9 if we wanted to do those. So here the square root of 0 is going to be 0. The square root of 1, if we plugged 1 in there, is going to be 1. The square root of 3 is about 1.7. The square root of 4 is 2. And the square root of 9 is 3. So when we go to graph this, this is what the graph would look like with some of these numbers, and I know I have them in different orders, but just to try to show you how we can pick either all numbers that have perfect square roots, or we can go to other numbers if we don't want to make our graph very large and have to go out the x-axis very a long distance. So here we would plot the points and then connect those points, and as you can see, it's not a straight line, it is an arc starting from the origin and continuing to infinity, or positive infinity. We are also going to be looking in this section about naming the domain and range of these functions. If you recall, the domain is the x value, range is the y value. So for this function, with it being a radical here, we want to find our x value, our domain, we would take what's underneath the radical sign and set it greater than or equal to 0. And that's going to end up being our domain, because we're not going to have any negative values for x. They're all going to be positive. Our range, we're not going to come any lower than this, because if we plug in the lowest number we can in for x, y, the lowest number that's going to be is going to be 0. So our range is going to be y such that y is greater than or equal to 0. If you look at these two pieces here, this kind of tells us that it's going to be in that first quadrant. and that's where our graph ends up. And if we want to take a look at another one, we can look at f of x equals the square root of x minus 3 under the radical sign and then minus 1. So again, we'll make an xy chart. With 5 spaces. So we'll use a 3 here. And one thing to be able to help you determine what number to start with, remember, take the radical, whatever's underneath the radical sign has to be positive. It has to be, well, I should say it has to be a non-negative number, which 0 is not a negative or a positive. So we have to set whatever is underneath the radical sign greater than or equal to 0, and then solve for x. So we would add 3, x is greater than or equal to 3. So that's where we can tell where our first x value is and where we need to start. So we'll start here, 3, and we'll just go down 4, 5, 6, 7 for our 5 points. So when 3 is underneath here and we plug it in, 3 minus 3 is 0. So 0 minus 1 is negative 1. If we plug in 4 here, 4 minus 3 is 1. The square root of 1 is 1. So 1 minus 1 is 0. If we plug in 5, 5 minus 3 is 2. The square root of 2 is 1.45. Minus 1 gives us 41. I think I said 0.45, but 0.41. If we plug in 6, 6 minus 3 is the square root of 3. The square root of 3 is 1.73. 1.73 minus 1 is going to be 0.73. If we plug in 7, 7 minus 3 is 4. Square root of 4 is 2. 2 minus 1 is 1. So that gives us our numbers that we can use to plug in for our graph. And I'll bring a paper of graph paper here. And you should be able to see the graph. Our chart here, this is our function. Here we know that x has to be greater than or equal to 3. That's where we can start. And then here we just graph those points. And here I actually had an extra point. I had 6 points. And you can see where the graph goes. So we know it's not going to go any further below here. And it's going to keep going to infinity, positive infinity, for both the x and the y. So our domain is going to be x such that x is greater than or equal to 3. And our range is y such that y is greater than or equal to negative 1. And again, both of these going into the positive infinity for both x and y. Okay, so now let's take a look at exponential graphs and functions. So if we have f of x equals 2 to the exponent of x. That means our x is in the exponent. Again, we are going to do an xy. With 5 spots. So if we enter in, and with x, we can have negative exponents. We just can't have negative underneath the radical sign. So if we plug in, say, negative 2, negative 1, 0, 1, and 2, that will give us a good variety of what's going on the left and the right side of the origin. So if we plug in negative 2, if you remember on Wednesday, we talked briefly about a negative exponent and how we can make that positive. If you remember, you just take everything here, drop it below a fraction of 1, and now it's positive. So now this would be 1/4. So when x is -2, y is 1/4. When x is -1, again, we will drop it below the line, and y will be 1/2. Now the next one, when the exponent is 0, if you recall, we've talked about it before, anything to the 0 power is 1. So it doesn't matter what it is, whether it's 1,000,000 or whether you have a ton of variables in it, anything to the 0 power is just that 1. 2 to the 1 is 2. And 2 to the 2nd power is 4. So if we went to graph this, we have this -2 and 1/4, and I will use a different color for the graphs, if I can find them. Okay, so -2 and 1/4 will be about there. -1 and 1/2 will be about there. 0 and 1 here. 1 and 2, and 2 and 4. As you can see, once it gets to the right side of the y-axis, it starts to take a real steep turn going up. Then we want to connect our points here. Now, one thing that we'll get to on Wednesday, but just so you know, anytime you have your exponents, your variable in your exponent, this line, as it comes down, it will never cross the x-axis. So when you connect your dots, just make sure that here it does not cross over the x-axis, or it would be considered wrong. And again, we'll go over this more in detail on Wednesday. But that would be an exponential graph with x being in the exponent. So basically you just plug numbers in and then graph those points. Now here, if we're looking at the domain and range of here, the domain being the x value, the x is going to keep going infinity to -infinity and +infinity. So the domain is all real numbers. The range, and again, we'll go over it more on Wednesday, but here when you have x in the exponent, it will never cross below a certain point. This one in particular, if it just has x here, if it had something like x minus 1, or this had 2x plus 5 or something like that, then those points, really, if you look at here and you put a plus and you have a 0 there, this right here would be where y is 0, and it would never go below that part. So if we had here 2x plus 5, then it would not go below the 5. You would have something coming like that, and it would never go below the 5. But again, we'll get into more of that on Wednesday. And so therefore the range on this one is going to be y such that y is greater than or equal to 0. And actually it's going to be greater than 0 because y will never be 0 because it won't cross that line. Okay, so this section, 7.7, you're going to do 1 through 14 all. Please email me with any questions you may have. If you get confused with the graphing, with trying to find out the domain and range, just give me an email or text, however you normally contact me, and I will try to work it out in a little more detail for you. Thank you.